Hi, welcome to Mathematics with Tom. I am Tom, and today we're going to take a look at section 5.2 in our text called Permutations. And cofactors. And this is actually going to be an example. We're going to, and we've derived the formulas at this point. So now we're going to try an example. And here's what we said. We said that the cofactor formula is for some AN matrix is it's A1J times C1J, where C1J is negative 1 raised to the 1 plus j, I guess. Oh, come on. Raised to the 1 plus j times the determinant of the sub 1j matrix. And j goes from 1 to n. Oh, whoops, it's the sum. Sorry, I gotta squish that summation sign in there. There we go. That looks terrible. But you know what I can do? Watch this. This is so slick. Let's just scoot it over just a smidge right there. And then I can erase that little mistake and put in a summation sign. Oh, man, that is cool. All right, there we go. That is our equation. So let's try it. I want to try it with a really clever matrix. It's going to be called the Tridiagonal Matrix. We'll start with it, so we'll call it T for Tridiagonal. We'll start with T2. So we're going to take the determinant of T2. That's going to be 2 minus 1 minus 1, 2. And let's see. Well, that's going to be a 4 minus negative 1 times a negative 1. That's going to be a 1, and that is a 3. Now, let's do this again. Now, let's try the determinant of T3. Well, T3 is this pattern. It's 2, negative 1, 0. Minus 1, 2, 0, 0, oops, no, that's not correct. It should be minus 1, 2, minus 1. Then we have 0, minus 1, 2. I'm going to take that determinant. Now, here's what we're going to do. We're going to apply the cofactor matrix formula. So this is I take 2 times, and then what I'm going to do is the submatrix. Well, the submatrix is 2 minus 1 minus 1, 2. Minus, because we just changed the sign because it's going to be a 1 plus 2, which is 3. So minus 1 raised to the third is a negative 1. We're just applying this. And then so now my next 1j is 2, so it would be the second one. So this would be a negative 1. And then the submatrix would be, the submatrix is minus 1, 0, minus 1, 2. And now we're to the A1, 3. Well, 1 plus 3 is 4. Negative 1 to the fourth is positive 1. So plus, and then the A1, 3 is 0. Oh, so that's going to be 0. And we'll just for practice, times the submatrix would have been minus 1, 0, 2, minus 1. But that's 0, so we won't go further with that third component, third term. Now, but I want to point something out. You can always rush off to just power calculations, but look at what this is. This is really just 2 times the determinant of T2. We already know that, so I don't have to calculate that again. Plus, this next one I have to calculate. That's going to be, it's going to be a minus 1 times 2. That's a negative 2 minus a 0, plus our 0 on the end there. So T2 we said is 3. So this is 2 times 3 minus a 2. This is going to be 4. Wow, we're going to take this one more step. Here we go. I think we can just fit this on here. That's right, the determinant of T4. T4, how is that going to work? Well, T4 looks like this. 2 minus 1, 0, 0, 0, oops, nope. Minus 1, 2, minus 1, 0, 0, minus 1, 2, minus 1, 0, 0, minus 1, 2. That is T4. All right, well, let's proceed the same way. So our first component, now we're going to go a little faster. Check this out. Is going to be our first Aij up here. We'll do this in yellow. Is the 2. So I go 2 times, and then I clear out row 1, column 1. But look at this. This subdeterminant that resulted, well, that's just T3. So I'm just going to write this as times the determinant of T3. Oh, I don't even need all those symbols. Let's just do times determinant of T3. Okay, now then I have a minus, or you could think of it as plus, minus 1 raised to the 1 plus 2 times, okay, now let's grab another color for this. So I'm going to erase that orange stuff. Oh, I didn't want to erase that much. Oh, well, now I'm going to grab my next component. So that's a negative 1. And then if I removed row 1, which I've already done, and this time I would remove row 2. So the resulting subdeterminant is a minus 1, 0, 0. It's that first column kind of written on. The third column, minus 1, 2, minus 1, 0, minus 1, 2. Plus, now notice they have zeros. So plus a 0. And then I'm going to have a minus a 0 term. Those are zeros, so we don't need to worry about those. But now let's keep going. So this becomes the problem of 2 times T3, which is 4. Then I'm going to have negative 1 times negative 1. That's going to be plus a 1. Now notice that I have this subdeterminant. Well, this determinant says you go through the same process. Here's my A11, so that's going to be a negative 1 times, look at the subdeterminant is, well, that's T2. So times the determinant of T2. Then we're going to have a minus, because the minus came, because we're working on this piece right here now. Minus, and I have a negative 1 times the subdeterminant. Well, the subdeterminant is this determinant with 0, 0, minus 1, 2. But that's a singular determinant of a singular matrix, so we know that is 0. And here we go. Our result is 2 times 4, that's 8, minus 1 times T2. T2 is, the determinant of T2 is 3, so this is equal to 5. Now, we're going to try this one more time. I know it's crazy, but we're going to do this one more time. And here's what I'd like to show you the other route. And it's easy to lose sight of this. We're going to find the determinant of T4. We know it's 5. But let's try it using row operations. So T2 minus 1, 0, 0. Minus 1, 2, minus 1, 0. 0, minus 1, 2, minus 1, 0, 0, minus 1, 2. Okay, well, let's just see if we get the same result. So I'm going to take row 2, and I'm going to add to that 1/2 of row 1. Okay, that's going to, now these are determinants, so I can actually use the equal sign. So this is going to equal, my first row is 2 minus 1, 0, 0. My second row becomes 0. Then I have a 2 minus 1/2. That's going to be 3/2. And then I'm going to have a minus 1, 0. And the other row, we're just copying the next 2 rows. 0, minus 1, 2, minus 1. 0, 0, minus 1, 2. Now, our next row operation will be row 3 plus 2/3 of row 2. Okay, now these are determinants, so this is equal, not just an arrow. So this is 2 minus 1. At least it better, otherwise either our properties are wrong or our row operations are wrong. But the properties should hold. That's our point. 0, 3 halves, minus 1, 0, 0. Now I take a minus 1 plus 1 is 0. Then I have a 2 minus 2/3. Well, that's 6/3 minus 2/3. That's 4/3. And then a minus 1. And I'll copy the fourth row. 0, 0, minus 1, 2. And now we're going to take row 4 plus 3/4 of row 3. So that is going to give me a 2 minus 1, 0, 0, 0, 3 halves, minus 1, 0, 0, 0, 4/3 minus 1, 0, 0. Now I get a minus 1 plus 1, that's a 0. Then I'm going to get a 2 minus 3/4. Well, let's see. 2 is the same as 8/4, and I take away 3/4, that's 5/4. You should double check me on that. Well, this is a diagonal matrix. So we said that the diagonal matrix now is just the product of the diagonal components. So it's 2 times 3/2 times 4/3 times 5/4. And look at that. Oh, that's just clever. Everything except for the 5 cancels, and it worked as we would have expected. That's how you use the cofactor matrix, and also how you can take another way to take the determinant. I hope that helps, and thanks for watching.